Okay, so I'll be talking today about the valorization of biomass waste from construction site to the production of gaseous fuels. So can you hear me okay? Uh, so just before
Yes, we can hear you.
all right then, you see, so I just want to thank you, the Recycling and Waste Management Summit Secretariat for inviting me for this summit. All right, so let's start then talk. All right, as I'm from Recife in Brazil, you see, it's just for you to find out where I live. Okay, so that's the Americas, and this point here in the Brazilian tip, that's where I live in a state called Pernambuco, and that's my city. And the city was colonized by the Dutch, and for 35 years, and the the Dutch has left Recife, after war with the Portuguese. They went to New York, and that's where they were settled. New York was, founded after Recife, through Recife, I would say that. So that's our city and our beaches. So just for you to let you know. And here, that's the civil construction residues that you have in Brazil, and over 50% of the received municipal solid waste, it comes from civil constructions residues. In the metropolitan area, there are about 3,000 to 4,000 tons a day, and part of it will be the wood. All right, and the waste wood takes account 6% of the all civil construction residues. And so in Recife, it would be around 200 tons a day, and that one cannot be reused because it would be like broken or damaged and cannot be used in civil construction anymore. So what they do with that? So in Brazil, most of the civil construction wood waste is dumped in landfills or in open dumps. And one problem that is could be recognized is the wood sample extracted from Sydney in Australia landfill showed little or no sign of decay after 46 years in the landfill. And the biodegradation of wood waste in landfills is very low or insignificant. And what happened is lignin, that's one of the main constituents of the cell wall, prevent microbial attack in the composition of the cell wall. And for this case, you see the amount of wood waste in the landfills that's very, very high, and that's reduced the lifetime of the landfill. For the reason, environmentally friendly technological routes ought to be investigated to use the waste wood as feedstock. And so that's the wood waste final disposal in Brazil. As you can see, that was in open dumps, but some of them are left in construction sites, some are left in the streets, and some go to sanitary landfill. And so that's a kind of a burden because they cannot degrade very often, in the due time. So the most challenging issue in civil construction in Brazil, as well as in other parts of the world, is to implement sustainable practices and to have an eco-friendly, large-scale use of the wood waste, as we know that dumping in landfills is not a correct solution. You see, so that's in our research, this one here, the collect the wood waste is in the residential building. All right, and I'm going to show the details in a few minutes. And then we have the energetic use of wood waste that can be like in combustion, burning, can be in bakeries, home heating, boilers or steam generator, or red tile factories. So we have a lot of use for that, you see, but some of them cannot because cannot be sold. And there is no recycling or the energetic use of wood waste. So the objectives of this work is to obtain data of the wood waste composition availability in a construction site to determine the physical, chemical, and energetic characteristics characteristic of the wood waste to evaluate the wood waste usage as solid fuel for direct burning and the use of wood waste as feedstock for gaseous fuel production using a bench scale gasifier and a 20 kilowatt downdraft gasifier connect to adapted auto cycle motor generator. In this case, in here, we are just going to show the results of bench scale gasifier and also going to show if they would be used as a solid fuel, what would be the amount of energy that can be extracted from the wood waste. In order to find out the kind of technologies that can use wood waste, you see in the conversion process, you can have like a fermentation to produce ethanol. So that would be the second generation ethanol. You see this one has to be hydrolyzed, the enzymatic or use acidic hydrolysis, or it can be liquefaction to produce a liquefied to produce biofuels. So this one here is a kind of pyrolysis. You can combust to produce heat. You can press to produce briquette and pellets. So that one here going to be sold as solid fuel. In the pyrolysis process, you can form like charcoal, gaseous fuels, as well as in gasification process. And also these gaseous fuels can be used to produce methanol or other like more advanced fuels and green fuels. And so that's one of the routes that the world is aiming to. All right, so we're going to be talking here about the combustion. You have done like pellets and briquettes, but our problem, you see, our approach would be in gasification to produce gaseous fuels that we're going to be showing you now. So the three steps that were used was like sampling and preparation. The second step, it was the characterization of the samples, and then there was like a production and characterization for the gaseous fuels. Uh, so the wood waste sampling was in the construction site using multi-familiar residential buildings. That's very common here in Recife, here in Brazil. The total construct area was 11,500 square meter and was using the pre-stressed concrete structure. A vertical ceiling used drywall and ceramic blocks. And so that's the construction site in various like phases of the construction. And so that's where they use the wood. All right, and some of them cannot be used anymore. So you can see here plywood, and so that's the residues. So that's the waste management that you can have in the construction sites. And when we get the samples and it did the gravimetric analysis, so that's the four main types of wood that been used in the construction here in Brazil. Mixed wood, that is a wood that made of many types of wood, pinus, laminated plywood, and resin plywood. Okay, so in here, so that's how you prepare. So you have like a knife mill, right? And then you have you get the sawdust and prepare the pellets. So the pellet can be used to analyze in our instruments in the lab. So that's our small pelletizer. So that's the wood waste that could be in form of pellets. So instead of having the big like plywood and the timbers, so you reduce that, and then you produce this kind of pellet that can be sold already as solid fuel for heating, for bakeries, and all this stuff as solid wood. And that's how you go and use that for our experiments. Okay, so that's the wood waste. So they are shipped here, use the machine, all right, the mill, and then you have how in the lab, the instrument that we did all the analysis, have a calorimeter that gravimetric balance that you do the approximate analysis, the 5 digestion to get the biomass composition, and the elemental analysis in order to verify the composition of carbon, hydrogen, oxygen, nitrogen, and sulfur. All right, and that's the GC, the gas chromatograph, in order to analyze the composition of the gases that came out from the gasifier. So that's a drone draft gasifier in a pilot scale that's a 20 kilowatt, and that's the bench scale gasifier that we use in the lab, and that was the one that we're going to show the results of our research. So that's the bench scale gasifier. See, there's a gasifier tube made of steel, stainless steel. And here we have the heater. And so we have in here the temperature, the thermocouples in order to verify the temperature inside the reactor. And here you have the valve. That one here, you pass first nitrogen to have like inert atmosphere. And they have all these valves here. They have a pressure gauge. And so in this pressure gauge, you can verify the temperature that the pressure that can be like achieved inside the chamber, and you can use that to control temperature and pressure and the residence time. So when you open the gate here, so you get here this sampler collector port, and after that they're going to go and the gases can be analyzed in the GC. All right, so the bench scale gasifier, this temperature that we did the analysis was 700 degrees C, 800 and 900 degrees C. The residence time, 3 minutes, that's going to be shown here, but we have done different residence time from 1, 2, 3, 4, 5, 6 minutes, and the result after 3 minutes were the same. So in that way, established that the residence time was 3 minutes. You see the initial mass that you use in the samples were 5 grams. So the results and the discussion, you see that in the civil construction in Brazil, there's a type of wood that they use, and we know that mixed wood came with 6-7% of their purchase, laminated wood 14%, pinus 11%, and resin wood 8%. So that's the percentage, and from the total amount that they have bought, it was 164 tons. So you got here the percentage of each type that was bought for the construction of the residential building. And the approximate analysis has shown here the results. The density for mixed wood was 800 kilograms per square meter, pinus 414, plastic coated plywood 519, and resin coated 521. Moisture content was very low, 7.6 to 10%. Ash content was very good. That one in the experiment was done at 600 degrees C, and there was a Marfan method, and also was used a little bit on the, you could get the results on the gravimetric, thermogravimetric balance. So you can see that the amount of ash was very low, and the weighted average concern, with the percentage of each wood was 1.29. That's very low for gasification. And so the ultimate analysis, you can see that the composition of the biomass could not, almost the same, it was very little variation. And so the weight average was first 6.6 for carbon, 6.58 for hydrogen, 45.34 for oxygen, nitrogen, 0.17, and the sulfur 18. That's very small because it has to be under, sulfur has to be under 1%. The heating values, it was very high. The low heating value in here, you see was in the range of 17 megajoules per kilo, and in the average was 17.8. All right, so that's on a dry basis. And here, when you start doing the gasification process for 700 degrees C, you see you get here the collection of the type of gas that was generated: hydrogen, carbon monoxide, CO2, methane, and nitrogen. You see this one here was in 20 air in the beginning, and the low heating value was it in the 8 to 9 megajoules per cubic meter range. So the average was 8.28 for 800. You see, they started having a better low heating value. It varies from 972 to 10.7, and the average was 9.95. For 900, you see that the average was 1014. You see the low heating value varies almost from 10. It was in the 10 megajoules per cubic meter range. All right. And another thing that you could verify here, it was the effect of gasification temperature on the low heating values for gaseous fuels. So that one here, you get the composition and get heating value for each gases, and we weighted. And so you can see here that from 700, that was in the 8 megajoules range. When we increase the temperature to 900 and 800, that was like a very good improvement of the temperature. And the another thing that you have to take in account is the yield, the gases yield. So the gases yield in cubic meters per kilo. You could verify here that the yield has increased when the temperature increases. All right, and for all of them is so when we multiply the yield by the heating value, you can get the energy that can come out from the gasification process. And that's what happened. The total energy produced, that is megajoules per kilo. And you verify that at 900, it was much higher than with the other one. You see, even though the low heating value was about the same for 800, 900, was in the same range, the production of gases was higher. So it makes the 900 degrees experiments more attractive than for 800, all right, for all of them. And so, so if you consider 200 tons of wood waste, uh, instead of being dumped every day in Recife in landfills, they can be used for power production. They would generate like 6,400 megawatt hour per month. And there is a Brazilian ProGD program that means distributed generation for electricity program, established values to purchase for electricity using residual biomass is $85.52 per megawatt hour. And if this one here, instead instead of being dumped, or if you use in like in a landfill, you see you can get here like 561 reais. That means 137 US dollars per megawatt hour. All right. And so this revenue may attract power and civil construction company to invest in this technology to produce electricity locally. So in that way, it will be a good way for you to produce your own energy and make a revenue on this. So the conclusions on my research was that 67% of the biomass used in civil construction consists of mixed wood. The proximate analysis have shown very high volatility and very low ashes. Is 1.29 that C, and that's very important characteristics for gasification. The wood waste low heating value was 17.8 kilojoules per kilo. The best results were at 900 degrees, and it could generate 12 gigajoules per ton. And for this one here, for plastic laminated wood and for wood, mixed wood in pinus was approximately 13 gigajoules per ton. And the all wood waste produced in daily in Recife was used for electricity generation through gasification process. They would produce 6,400 megawatt hour per month. And this revenue can be like 547,383 per month. In this one, here is a significant amount of money, and that could attract investor to use this kind of technology. So instead of dumping, you can use to produce electricity. So it's the one waste to energy program. And so the use of gasification would be an interesting way to valorize the wood waste while providing sustainable electricity and reducing or even eliminating the environmental problems caused by dumping of biomass in landfills, whereas it not degrades significantly, as I showed. So this one here, I would like to thank the AES-TET, this American electric company here in Brazil, and ANEL, this is a Brazilian electrical company, for the R&D funding, the university, all right, for incentive, and my team at Olicon, that's the Fuel and Energy Laboratory at University of Pernambuco. So that's the acknowledgements, and like again to thank the Recycling Waste Management Summit organizers for this invitation. And I would like to end my presentation showing my the beaches here where I live, all right, and the Portugalinhos, that the most beautiful beach in Brazil. And I invite you to know Brazil, to know our city in here. And obrigado, all right, thank you. Obrigado, that's how you say thank in Portuguese, and that's my directions. And this is it. So I'm ready for any question that you may ask. Thank you.